Hi, I am Keshav and I am going to solve 6th question for MAT104 Endsem. So this is our question, and in first part we have to tell what is the real life phenomenon that is captured by this if the ODE represents spring mass system. So first of all you can see it's a second order ODE and it has missing y dash term, no y dash term. So it means that it is undamped, and also there's a external force which is represented by this term. And let me write some property. This is a direct delta function, so let me write some properties of direct delta function, which are direct delta of t is equal to infinity when t is equal to 0, and it is 0 when t is not equal to 0. Also, direct delta of t minus a is infinity when t is equal to a, and 0 when t is not equal to a. So here when t is equal to 3 pi, then there will be an infinite force act on the system. We can say this is a hammer stuck to the mass. This is a hammer stuck to the mass of the system. So this is the real life phenomena captured by this direct delta function. So now moving on to the B part. In B part we have to sketch the graph of the solution without actually solving it, just by using our intuitions. So as this is our OD, y double dash plus 16y is equal to 4 times direct delta of t minus 3 pi. So this will produce a value only when t is equal to 3 pi. So before t is equal to 3 pi there will not be any graph, and after t is equal to 3 pi there is a displacement due to this force, and this the graph may be the graph will maybe like any of the trigonometric function like sine or cos. So this is my intuition on this. So let's move on to third part of this question, in which we have to solve the ODE and sketch the solution of the graph. So before solving, I'll write some formulas which I'll be using in this. So first one is u t minus a is equal to 0 when t is less than a, and 1 when t is greater than a. This is basically a unit step function which acts as on and off switch. Other formulas are Laplace of f dash t is equal to s times Laplace of ft minus f0, and Laplace of f double dash t is equal to s square Laplace of ft minus f s times f0 minus f dash of 0. So we have one more formula, that Laplace of del t minus a is equal to e to the power minus as, and we can take Laplace both sides in an equation, and equality will hold. So this is our equation, y double dash plus 16y is equal to 4 times del of t minus 3 pi. Here I am taking Laplace, so L of y double dash plus 16 L of y is equal to L of 4 times del of t minus 3 pi. So just expand it, s square L of f plus minus s times L of f0 minus f dash 0 plus 16 times L of f is equal to, now using that property for L of delta, we'll write this side is 4 times e to the power minus 3 pi s. So now let's take Laplace of f as capital Y for now, for our ease. So our equation is s square y minus, this is s times, this is 0 by our initial condition, so s times 0 minus, this is also 0, plus 16y is equal to 4 e to the power minus 3 pi s. So now taking y common, so y s square plus 16 is equal to 4 e to the power minus 3 pi s. So our y will be now, ys is 4 e to the power minus 3 pi s upon s square plus 16. And yes, so now ys, we have assumed a Laplace of ft as ys, so ft will be now Laplace inverse of ys. So this will be equal to Laplace inverse of, we'll put value of f ys, which is 4 e to the power minus 3 pi s upon s square plus 16. So this will be 4 upon s square plus 16 times e to the power minus 3 pi s. So this is a property that Laplace inverse of omega upon omega square plus s square is equal to sine of omega t. So in this case our omega is 4, and this 4 upon s Laplace inverse of 4 upon s square plus 16 will be equal to sine omega t. but still we are left with this term e to the power minus 3 pi s. So for that we'll use another property, which is Laplace inverse of e to the power minus as times fs is equal to f of t minus a multiplied by u of t minus a. This u is that unity function which I mentioned earlier. So fs is equal to sine 40 here, which we have seen how, as omega is equal to 4. So now ft will be, this is ft. So writing ft is equal to sine, applying this property, sine 4 t minus 3 pi u t minus 3 pi. So I'm writing it, simplifying it more, sine 4t minus 12 pi times u t minus 3 pi. So we know that this switch function will give 1 when t is greater than 3 pi. So yt is equal to sine 4t minus 12 pi. Sorry, ft is equal to sine 4t minus 12 pi, which is nothing but sine 4t. So this is our final solution, and also we have to plot graph of this. So this is nothing but a simple sine 4t graph, but the thing is it will start from 3 pi. So this is the graph. Sorry, you can't see that. So this is the graph, and this will go till infinity as there is no damping here. And also we have to compare this. So on comparing, I found that at that time I only know that the graph will start from 3 pi and there will be a trigonometric function, but I didn't know the exact which function it is. So now I know that there is a sine function only. This is the graph of sine 40. So that's it for 6th question. Thank you for watching.